Hi there, welcome back to my channel. In this video, I'll be taking you through triple integral in cylindrical coordinates. So in our previous lessons, we've delved into double integrals in polar coordinates and others. So we continue through triple integral in cylindrical coordinates. What are the cylindrical coordinates? So in our sessions when we're dealing with cylindrical coordinates and how to convert from the Cartesian, spherical to cylindrical coordinates and vice versa, we realize that cylindrical coordinate has three main parameters: r, theta, and z, right? So it's like a polar coordinate in advanced form by adding a z parameter to it. You can see clearly that our integral is the z, the x, the y. So my very first inner limits are for z. So I'll say that z is greater than or equal to x squared plus y squared and less than or equal to square root of what? X squared plus y squared. The next one is x. X will be greater than or equal to 0, less than or equal to square root of 1 minus y squared. Then finally y. And y, which is going to be greater than what? -1, but less than or equal to what? 1. So these are the three things you need to put down anytime you are given this problem. The problem says you should evaluate by converting into integral in cylindrical coordinates, right? So to convert this into cylindrical coordinates, all we need to do is to get the cylindrical coordinates version of this sort, Cartesian coordinates. Remember that cylindrical coordinate we need r theta, and always our theta becomes what? The very last one. So the very last here gives us what? The nature of the theta. Okay. So see, if you have -1 to 1, remember that our y is from -1 to 1, -1 to 1. That should tell you that this is going to give a complete circle, right? A complete circle. A complete circle. Right. So let's see something here. Okay, so let's analyze and draw everything all right here before we come to that conclusion. Before we come to this conclusion. So from here, you know that x squared plus y squared in polar coordinate or in cylindrical coordinate is always r squared less than or equal to z, less than or equal to, here becomes what? Square root of what? R squared, that will be r. That is for z. Now for x, so see something, this should have given us a complete circle, as I said, but the x is going to restrict us. So we should always look out for x before we make conclusions. X is saying that x is from 0 to what? Square root of 1 minus y squared, right? And this is a curve. So meaning x is taking all these parts, right? Therefore, though the y is from what? -1 to what? 1, but since the x is taking only the upper part, meaning that we are not taking, so 1 minus y squared is going to be a curve, right? So right now x is taking what? From 0. So from 0, so x is actually taking this part. Know that x is taking this part. So from 0 towards this side. So everything here, because x has two parts, right? Whenever you see x this way, x has the left and right, but y rather have up and down, but x has got left and right. So if x is from 0 to this part, meaning the right side of what? X, right? So we want all this side. And now y2 is giving us from 1 to -1, meaning that it is a semicircle. A semicircle. So our angle will be from what? -pi to pi. -pi to pi. Okay. So theta will be greater than or equal to -pi on 2. Less than or equal to less than or equal to pi on 2. So let me clean it and write it well. So I'm trying to say that you're going to have a 180. Okay, 180. You know, 180, we'll be having -pi on 2 towards pi on 2. That will give us what? 180. Okay, -pi on 2 to pi on 2. So we surely have our -pi on 2 less than or equal to theta less than or equal to pi on 2. So from this problem, we have been able to deduce the parameters needed for our cylindrical coordinates. Okay, we have r, we have theta, so we have z, we have theta, right? We have z, we have theta. Then we know that r will surely be what? From 0 to what? 1. From 0 to 1. Okay, because here x here was in place of the r, x here was in place of what? R, and it's starting from 0 to this section. So let's see something here. The reason I'm saying r is greater than or equal to 0 but less than or equal to 1 is from here. You realize that here will tell you that r is 0. Okay, then for this side you're going to get x is equal to, always take the equality from it, inequality from it. So s, and we only want equality. S is equal to square root of 1 minus y squared. I'll have s squared plus y squared to be equal to 1. R squared will obviously be 1 and r will be equal to 1 plus or minus 1. But since s is greater than 0, we only take the positive side. So r is what? Greater than or equal to 0 but less than or equal to 1. Now all our parameters are set, right? So we're able to move. So when you move integral on the theta side, we're having what? Negative pi on 2 to pi on 2. On the r side, you're having 0 to 1. Then the z side, you're having r squared to r, right? Of the function. Now the function xyz becomes what? r, then remember that always for cylindrical coordinates, the dA is always equal to r dr dz d theta, okay? R dr dz d theta, okay? Or you can say r dz dr d theta. That should be the best. So the z should come first. So the r d theta will be the last, but this r is supposed to come. So r here. Now our x is the same as what? R cos theta. Our y is the same as r sin theta, and our z is z. Our z is z, okay? So the z, the r, the theta, as simple as that. With this, we have set our parameters right and we are about to move. So here we'll simplify and we're going to get integral from negative pi on 2, right, to pi on 2, then integral from 0 to 1, then the z. So let me simplify further. I'm going to have integral from r squared to r, and I have r cubed, right, r cubed, then we're going to have this r cube, right? Then I have z r cube cos theta sin theta, right? So that one I can make it what? Yeah, you let me make it cos theta sin theta. D the r the theta. At this point, in doing my first integration, I'll have z out. I'll have integral from negative pi on 2, integral from 0 to 1. Then I'll have what? Z squared over 2 from r squared towards r at the upper and lower limit, right? Then I have my dr d theta. So the first one is gone. So with this, I have my integral from negative pi on 2 to pi on 2, integral 0 to 1. When I put r squared, r here, I'll have r squared over 2, right? So I'll have r squared over 2 minus r to the power 4 over 2, right? So I'll have all these two one here, okay? So once I have this thing here like this, so I'll have my, remember I have cos theta and those stuff here, cos theta sin theta here, and I have the r d theta, okay? So with here, I'm almost through, and what's this? I simply have to take half out, okay? So I have half out of the expression. And remember that I can make this one sin 2 theta, so I can have 1 over 4 out instead. When I have 1 over 4 out, integral negative pi over 2, integral 0 to 1, then I'll just do r squared minus what? R to the power 4 minus r to the power 4 all over what? 2, but the 2 has come out, so let me take all over out. So that's, I simply get this expression here. Then I'll have sine 2 theta. Remember sine 2 theta. That is why I took the half and multiplied by the other half to give me 1 over 4. Now I'm going to have the, so I'm going to have the r d theta, right? So here I'm going to do integral with respect to r. Okay. So with respect to r, I have 1 over 4 out. Integral from negative pi on 2, integral. So at this point, I'm integration with respect to y. So let me do it straight away here. So I'll have my expression to be r to the power 3 over 3 minus r to the power 5 over 5. My limit is 0 to 1, right? And I have sine 2 theta. Then the